side-side-side similarity and using the side-side-side similarity theorem. In this video, we're going to learn what that theorem is, remind ourselves how to match up the corresponding sides, and then look at some common problems. The side-side-side similarity theorem says if the ratios between corresponding sides of triangles are the same, the triangles are similar. So this is another shortcut, because if we just know that we have 3 pairs of sides with the same ratio, we don't need to check the angles. Please remember that triangles are special. In other polygons, you need to still check both the ratios and the angles. Making sure that you match up corresponding sides is going to be crucial here. So let's take a look at a method for doing that. I know I've gone over this before, but as a reminder, what I like to do is I go short, and then I go medium, and then I go long with one triangle, and then I set them all up, getting ready to make them into fractions, and then I do short, medium, and long from the other triangle. So I did short, medium, long, short, medium, long. So then I know which sides correspond with each other. Two triangles may be turned or rotated or reflected or any sort of transformation in addition to being similar. We might have 2 right triangles, so we need to use the Pythagorean theorem. And you might have 2 triangles that are overlapping each other. Alright, so looking at the turned triangle, we want to know, are the 2 triangles similar? And if so, we're going to write our similarity statement. So looking at the larger triangle here, I have 27, 36, and 45 going in size order. In the larger triangle, or the smaller triangle, we have 12, 16, 20. So we're going to do 12, 16, 20. Now let's reduce those fractions. And we get 27 over 12. Those are both divisible by 3. We get 9/4. These are both divisible by 4 here, so we get 9/4 again. These are both divisible by 5, and we get 9/4 again. So all 3 are the same. Our similarity statement, if I start off with triangle ABC, is similar to triangle, alright, so AB was the short side, so I want the short side over here. And BC was the long side, so I want the long side over here. So it's actually, if we're naming them in the same order, similar to triangle FED. If we're given 2 right triangles, so let's say this is 3 and then this is 5, and let's say this is 6 and this is 8, we need to solve for those missing sides before we can say whether or not the triangles are similar. So let's solve for this. I'm going to call this side X and this side Y, just so I'm not getting confused. So I have 3 squared plus X squared equals 5 squared. And in the other triangle, I have 6 squared plus 8 squared equals Y squared. Don't forget to make the hypotenuse the C value, the value by itself. So X squared equals 25 minus 9, which is 16, so X equals 4. And then, let's see, this is 36, this is 64, so Y squared is 100. So Y equals 10. So we double here, we double here, and we double here. They all have a ratio of 1 to 2. So triangle ABC is similar to triangle PQR. Another common type of problem, we have this overlapping triangle here, and let me get the missing value here. This is going to be 27. This is a really common misconception here. Or common mistake. Not adding the pieces together. Because over here on the right, kind of on the top side, in the large triangle, this side length is 28. And in the large triangle over here, this side is 24 plus 8, which is 34. And then the bottom is already the full side, so that's 36. In the smaller triangle, we have 27 is that long side, 21 is already given, and 24. So when I go to write them all out, for the larger triangle, the triangle on the outside, my shortest side is 21, then I have 24 and 27. And for the smaller triangle on the the larger, sorry, I just did the smaller triangle. Now I'm going to do the larger triangle. So now my colors are backwards, sorry. We have our smallest side is 28, and then 32, and then 36. And since all of these reduce down to 3/4, then we can say triangle ABC is similar to triangle DBE. Alright, don't forget to summarize your notes. Make sure you write down what the theorem is, how you match corresponding sides, and maybe something you should remember while you're trying to write the similarity statements.